What we are looking at today in your book is lesson 59. Okay, it is entitled Using Fractional Exponents. Using fractional exponents. Okay, if you're looking in your book, if you're on the same page as me, that's page 420. It starts off with the first paragraph. It says exponents of the form m over n, where m and n are integers and n does not equal 0. The reason n can't equal 0 if it's in the denominator position is because any fraction divided by 0 is irrational, right? It doesn't, and in fact, it's imaginary. It doesn't exist. Okay, these are called rational exponents, which means there is an answer. Okay? Rational exponents can be written as radical expressions. So we're going to be working with radicals. Not just square roots, but cubed roots and even further than that. Okay? The first rule that we come up with, okay, is something called rational exponents property. Rational exponents property. Okay, you'll see that on that first box. It says for m and n integers, okay, and again, n cannot be equal to 0, okay, that if I have a to the power of 1 over n, okay, we've got a, which is a number, okay, with an exponent that is a fraction, that this is going to be equal to the nth root of a to the first. So what you see, okay, is that this number in the numerator position goes with my a into the radical. The n is my root. Okay? Do we see where those things go? The opposite will also be true. Okay? That if I have the nth root of a to the first, that what we should end up seeing is that my root here will be divided by my exponent. Okay? I'm going to pull out the a, and I'm going to take the exponent divided by the root. Okay? Would be how we would do that in reverse. Okay? Do you follow me so far? Okay? All right, let's scroll down so we can see another part of this, which is if I have a to the m over n, okay, that's going to be equal to, what is going to go inside that radical? What? A. What is the root? N. Okay, what is the exponent of a? M. Okay, we can either write it like this with m in there, or we can have the nth root of a where all of this is to the power of m. Either way. And that's important to see that both of those are the same thing. They are equivalent to each other. Okay, they are equal. Because we're going to see something that's going to look like that right-hand side, you need to know that it's the same as what we're seeing here. Okay? Okay, these two things are the same. Okay? That's the rational exponent property. Okay? Radical expressions of the form the nth root of a are called nth roots, which means we can do as many different roots as we want, right? You can have the 7th root of a to the 4th, you know, anything like that. Okay, we're not necessarily worried about that because we're looking at things algebraically. Okay, we're not going to be doing a lot of this in our calculator. Okay, all right, let's look at another property. If this will, here we go. And the reason I'm doing this without typing it out is because you can't really type a lot of this out. It doesn't really let you do this. All right, properties of nth roots. Okay, properties of nth roots. Okay. And b is greater than 0. Okay, we have what is called the product property. What does the term product mean in math? Multiplication, very good. Product property. This is where I have the nth root of AB. Okay, this is the same as the nth root of A times the nth root of B. And we've seen this before whenever simplifying radicals. If I had the square root of 5 times the square root of 3, I can set that and say that that's the same as the square root of 15. Do we remember that? Okay, that's the same thing that's taking place here. If I'm multiplying two roots or two numbers that have the same root, then I'm multiplying them by each other and keeping them under the same root. All right? The nth root of AB is equal to the nth root of A times the nth root of B, and vice versa. Okay? The nth root of A times the nth root of B is equal to the nth root of AB. Then we have the quotient property. What is the quotient of something? Division. Quotient property is division. Okay? So if I have the nth root of A over B, that is the same thing as the nth root of A over the nth root of B. Okay, those are equivalent forms. So if I had the square root of 4 over 9, that would be the same thing as the square root of 4 over the square root of 9, and I could simplify from there. Okay, which would give me 2/3 if I was thinking about it. Okay, do we understand that? Hopefully. All right. Then we get a big box on page 421. Okay, and these are different properties of rational exponents. Okay, we've got, and I'm going to read this. You can see this on page 421. We've got the negative exponent rule, or negative exponent property, which means if I have a to the negative exponent, that is going to be equal to 1 over a to the positive exponent. And we should remember that if we drop a number with an exponent below or move it across the division bar, I get the same exponent but with the opposite sign. Is that correct? We're familiar with this? Okay, the zero product property. Anything to the zero property, or sorry, anything to the zero exponent is 1. Doesn't matter what it is. Okay? Doesn't matter if it's a variable, doesn't matter if it's a number. Anything to the 0 power is equal to 1. Then we have the product of powers. So a to the m times a to the n is equal to a to the m plus n. Okay? Whenever we multiply two variables with different, or the same variable with two exponents, we add up their exponents. The same thing with division, except in reverse. A to the m over a to the n is equal to a to the m minus n. Okay? The power of a property. If I have a to the m to the n, that's equal to a to the m times n. Okay? I know this should be review. Right? Does it seem like it's review? Hopefully. Then we have the power of product property. Okay, that is, if I do a, b to the m That is equal to a to the m times b to the m. I'm taking both of those things to that same power. And then finally, that same principle but applied to division, the power of quotient property, a divided by b to the m equals a to the m over b to the m. Okay, so those are rules that are helpful to write down if you don't already know them. And that's it, mainly for that box. So what we're going to do now is we're going to actually move into our work, okay, which is right here. Okay, this says to simplify. All right, so what we want to do here is we want to take as much out of the root as we possibly can. But notice first that it is a third root, not a square root. So we're going to break 216 down as far as we can. Okay, what can I divide 216 by? 2. Okay. What is 216 divided by 2? Would it be 109? 108, sorry, 108. We could take 108 divided by 2. Is that what, 54? 54. 2 is probably 27. Now I can make a change. I can divide by 3. That's going to be 3 and 9, 3 and 3, right? Now, because this is a cube root, in order to take a number out, I have to have 3 of them. Okay? Does that make sense? Do I have 3 of anything here? What do I have 3 of? I got 3 2s and 3 3s. All right? So I'm taking out 1 2 and 1 3. Okay? What is 2 times 3? 6. Okay? So I can take out 1 6. Now, if you'll remember, what is the relationship between 3 and that 18? I'm going to take 18 and do what with 3? Divide it by 3. What's 18 divided by 3? 6. So I get 6x to the 6th is the simplified version of that. Okay, do we understand that? Do we understand taking the exponent of x and dividing it by the root, right? That was one of the very first things that we looked at here. Okay? Number 2 wants us to do the opposite of that. It wants us to put this in radical form. Okay? So, if I make a radical here, what goes inside the radical? 8. What is the exponent to 8? 5. What is the root? 3. Okay? Can I write this another way? Right? Remember I showed you that there are 2 ways to write that. Where else can I put that 5? I could put it all the way on the outside here. Okay? Let's go ahead and just plug this in our calculator. What is 8 to the 5/3? Let's see. All right, let's turn that on, clear some things out here. 8 to the 5/3. Yeah, you need to make sure that you use parentheses there. Otherwise, what you're going to end up doing is you're going to take 8 to the 5th and then divide that answer by 3. We don't want that. Our answer should be 32. Okay? So we should see that that matches up with which answer? C. Okay? We match this up and our 32, okay, with that right there. Okay? Hopefully we're writing some things down. Okay, because we will see questions like this. I think that this question matches up with A and B. This is going to match up with A and B in your homework. All right, so I want to make sure I know what I'm doing here. Let's come to question number 3. 3 is just like number 1, right? Except whenever I break 256 down, am I looking for 3 of a number? What am I looking for? 4 of a number. So we're going to take 256. Jose, help me out. What are you going to divide that by? Divide it by 2, and what do you get? Probably helps to have a calculator. Anybody help him out? 128. Divided by 2 is probably 64. Good job. 2. 32, good, 2. 16, 2. 2. 2. All right, so we're looking for sets of how many? 4. So I got 1, 2, 3, 4. Do I have another? 1, 2, 3, 4. All right, so what number is going to sit on the outside? 2 and I'm going to multiply those, right? So what I wind up with 4. Okay, this z to the 16th. What am I going to do with that 16? Divide by 4. All right, what's 16 divided by 4? 4, so I should get 4z to the 4th. We're beginning to understand this a little bit better, more and more. Okay, good. All right. Number 4 gets a little tougher, okay, because we want to simplify this. Assume that all variables are positive. Okay, what do I want to do with these exponents here, with that exponent right there? Multiply, okay, and distribute is correct. So I get a to the what? 16th, and b to the 4th, okay? Now I want to come over here to this guy. What is the 6th through to b to the 6th? Just b, because 6 divided by 6 is 1. So I wind up with just b out here. What do I want to do with a to the 16th, b to the 4th with this other b? Distribute, but all of this is attached together. So I'm going to get an answer of a to the 16th, but b to the what? 5th, right? Because it's my product power. Because that is a b to the 1st, I'm going to take 4 plus 1 and get 5. Okay, a to the 16th, b to the 5th. Am I going too fast for anybody? Are we able to get this down? Hopefully. That's the reason I wanted to show you all those rules before we started. Okay. All right, let's simplify this. 125 to the 1/3. Well, if I do this, I'm going to get, if I put that in simplified radical form, okay, I would get to the 1st here in the cube root there, right? Plus the what root of 16? No, look, to the square. Okay, so does anybody know what the cube root of 125 is? 5. Good. So the cube root of 125 is 5. What is the square root of 16? 4. All right. So what's 5 plus 4? 9. Okay, do we see how sometimes finding the simplified root is easier than leaving it with a fractional exponent? Okay? I know some of us knew that the cube root of 125 was 5. Basically, if we take and we find a prime factorization of 5, we see that it's 5 times 5 times 5. Okay, and that's why that works out that way. Okay? 6. All right, let's see what we can do with 6. Okay, the approximate number of blood cells B passing through an animal's major arteries each millisecond is given by B equals 17 m to the 4/5, where m is the animal's mass in kilograms. Find the number of blood cells passing through a major artery each millisecond for a 32 kilogram wolf. Okay? Mass. So what am I substituting in for m? 32. So what we're saying is that B equals 17 times 32 to the 4/5. Okay? So let's see. Let's take that. This would be 17 times what? Can I change 32 to the 4/5 into a simplified root? What is the root? The 5th root of 32, 32 to the what? 32 to the 4th. Okay? All right. We could also write that as 17 times the 5th root of 32 all to the 4th if we wanted to. Could I plug all of that in my calculator? I probably could. Or we could even just take the 5th root of 32 to the 4th. But let's just do the 5th root of 32. Okay? Let's take 32 and break that down. Okay? We could divide it by 2 and get 16, 2 and 8, 2 and 4, 2 and 2. How many 2's is that? 5. All right, so if I'm looking at just this portion right here, what I can do is I can say that this is 17 times 2 to the 4th. Okay, because the 5th root of 32 simplifies to 2. Did we get that much? Okay, now I've got 17 times 2 to the 4th. Well, what is 2 to the 4th? 16. So I'm getting 17 times 16. 272. 272. Okay, so 272 blood cells is our answer. Okay. What time are we? 36 is what time we're out of here, correct? All right, so hopefully we can get through these last few questions. Let's rewrite x to the 5 halves. Let's see, what does this come into? How do I rewrite that as a radical? The square root of x to the 5th, okay, equals 32. Okay, if I want to solve for x, okay, make sure I've got that right. Yep, looks right to me. Okay, how do I undo a root by an exponent, right? So if I square all of that, what I'm going to get is x to the 5th equals 32 squared. Well, what is 32 squared? It's probably a pretty big number. 1026. All right, and how do I undo an exponent? What's that? What's 24? Oh, it's 1024. Okay. All right, how do I undo the 5th? 5th root it. Yep, 5th root it. So x equals the 5th root of 1024. So what we want to do is we're going to take 1024 and break it down. All right, what is 1024 divided by 2? Is that 512? Okay, 512 divided by 2. 256. 2. What is it? 128. 2 is 64. 2 is 32. 2 is 16. 2 is 8. 2 is 4. 2 is 2. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So how many 2's can I take out? 2. What's 2 times 2? 4. X equals 4. Is this way over anybody? Are we kind of getting it? Okay. Let's move on to number 8. I know I'm going quickly, but my hope is that we cover as much as possible and then you go back and rewatch it and slow it down. Okay. All right, a little bit tougher. 2x plus 17 to the 1/3. Okay. So this would be the cubed root of 2x plus 17 equals 3. How do I undo that cube root? No. Cube both sides. Cube both sides. So I'm going to get 2x plus 17 equals what? 27. Very good. All right, now we're just solving for x. What do I do with the 17? subtract it. Okay, so I have 2x equals what? 10. Divide by 2, x equals 5. Was that easier than we thought it might be? Okay, x equals 5. Very good. Problems? I don't have actually a watch on, so that makes that hard to do. All right, number 9. Simplify. Assume all variables are positive. Okay. Let's see here. We know that x, this is going to be x to the what? Anybody tell me? X to the 4th, because we're going to do 20 divided by 5. So we know we're going to get x to the 4th. The rest of this is 3,125, right? And we want to the 5th root, so we want to find groups of 5. So let's start off by dividing by 5. I think that's 625. Divide by 5. 125. 5 is 25. 5 is 5. So how many 5s do I have? 5, which I'm going to get to pull out how many? 1. So I get 5x to the 4th is the same as the 5th root of 3,125x to the 20th. Okay? All right. And we have 3 49ths to the 1/7. Okay, what am I going to do with the 49ths and the 1/7? Multiply them. So we're doing 49 over 1 times 1/7. So that's going to be 49 divided by 7. What's 49 divided by 7? 7. So I'm getting 3 to the 7th. Actually, yeah, 3 to the 7th. What is 3 to the 7th? 2,187. All right, last question. All right, write the rational exponent as a radical expression. Okay, so what goes inside my root? 6. What is the root? 3. And what is the exponent? 1. And I don't even have to include the 1. But I should get the 3rd root of 6. Okay, so we covered a lot of information really quickly there. I'm going to hit stop on the video. My biggest recommendation to you is that if you begin to struggle with this, begin to struggle with your homework tonight, go back, rewatch the video, slow it down, take notes as you need to. We're going to stop.